Hey, what's going on, everyone? It's Philip here, and welcome back. So in the last video, we covered how to FOIL and distribute. So we were given a problem like this here, and you have to multiply it out. So in this case, it would be x squared minus 9 plus 2, so it would be minus 7x, and then minus 18. This is how you FOIL. So I covered how to FOIL last video. So this time around, we're going to go, instead of going from here to here, we're going to figure out, if you're given a problem like this, how to go from this step to this step. Alright, so in this example, we have x squared minus 3x minus 40. So the way you factor is you have you draw parentheses. That way it looks like, actually let me go back. You draw parentheses here, because you're going to write it as a product. And so the first term that we're going to have here has to be what you can multiply to get this first term. So what can you multiply to get x squared? You can multiply x, and x times x is x squared. So we're going to have x here and x here. It's going to be the first part. And then we're going to have a number, a plus or minus a number on each of these parentheses. So the way you figure that out is you look at this 40 and you look at this 3, and you have to look at these signs too. So in order to get the term, this might be a little confusing at first, but you have to find two numbers which will multiply to get you negative 30, and added together will get you negative 3. So let's just look at the the factors of 40 first. So you can multiply 1 times 40. You can multiply 2 times 20. You can multiply 4 by 10. Or you can multiply 8 by 5. Those are all the factors of 40. So, and you can do pluses or minuses here too. So 1 times 40 is 40, but 1 minus 40, 1 plus 40, that's not going to get you 3. Same with 2 and 20. 2 minus 20, whatever, you're going to get negative 18, positive 22, negative 22. So that's not it. And 4 and 10, you'll get 6 or 14. And 8 and 5, you can get a 3. If you subtract 8 from 5, you will get a negative 3. So we'll put an 8 here and a 5 here. And now you see know which signs. So since it's a negative 3, we're going to put the negative 8 here and the positive 5. So when you add them together, negative 8 plus 5 will give you negative 3. And if you multiply them together, negative 8 times 5 equals 40. So it's a little complicated to get your head around first, but the more practice you get, the better you'll get at it. So so what am I really doing here when I'm factoring, like applications? So a lot of times you'll get questions where this is a function. So you have x squared minus 3x minus 40 is equal to f of x, or I guess y, and you'll be asked to find the x-intercepts, so when y is equal to 0. So in other words, when is x squared minus 3x minus 40 equal to 0? So when you factor here, you're writing it as a product, and you think about it like x. Let's say you have two variables, x times y equals 0, right? In order to get something to equal 0, either this x or this y has to be 0, right? Like 0 times 1 is equal to 0. 0 times anything is equal to 0. So either this x or this y has to be equal to 0 in this product. So if you think of this x minus 8 is x, and this x plus 5 is y, as this product, x minus 8 has to equal 0, or x plus 5 has to equal 0. Does that make sense? You're looking at this product, right? So x minus 8, you just move the 8 to the other side, so x has to equal 8. And if you move this 5 to the other side, minus 5 on both sides, x also equals negative 5. So these are the solutions in which x can equal to in order for y, or the function, to be 0. And what I mean the function is graphically, because this x squared minus 3x minus 40 is a parabola. So if you take a look here, I just graphed it on Desmos, x squared minus 3x minus 40. You get this parabola here. And since we solved the zeros, x equals negative 5 and 8, you can see here, it's a little hard to see, but this is negative 5 here. It's like midway between negative 10 and 0, and this is an 8. It's counting by 2s. This is 2, 4, 6, 8, and 10. So this is positive 8. So these are the zeros in which it will cross the y-axis. So that's just some application for you. So anyway, so let's go over a few more problems. So let's say you get a problem like this. So you have x squared minus 49. So if it helps, you can think about it as x squared plus 0x minus 49. If you think about it, so you have to find something that multiplies to get you negative 49, and if you add them together, you get 0. So think about it, you have to add and subtract the exact same number if you're adding or subtracting to get 0. So so in other words, what's the square root of 49? Because you have to find the same number. So 49 is 49 times 1, obviously. But that's not going to get you 0. There's no way you can get 0 by adding or subtracting 49 and 1. But 7 and 7, if you subtract them, you'll get 0. So the way you get your parentheses here is you do plus 7 and minus 7. And these are your two solutions to factoring. And if you were to if you got a problem where you had to find the y or the x-intercepts, or when this is equal to 0, if you set this equal to 0, you have to set each one of these factors to 0. So x plus 7 equals 0, x minus 7 equals 0, and then your solutions will equal positive or negative 7. And that'd be your answer if it was equal to 0, or if you're just given this expression, then you just stop at this answer, because you can't solve it if you don't have it equal to 0. So, and then we're going to go over one more example, just so you know what to do in different situations, because in each of those past problems, you only had x squared, but now we have a number in front of it, which makes it a little more difficult. So, the first thing you'd normally do is look for a GCF. Let's say if I can factor something out, but you can't. Like, let's say this was 3x squared minus 12x minus 27. Sorry, my handwriting's kind of bad. I'm just writing fast. You would be able to factor out a 3 here. So then you just have the x squared minus 4x minus 9. And you could just factor it out so that way you'd make it easier for yourself. But since we don't have that here, we can't actually factor any numbers out other than 1, but that doesn't matter. You'll just get the same thing. That doesn't help us. So there's two ways to write this. So in the first term, we're going to write the parentheses as always. And so there's two ways we could write this. We're going to have to just figure it out or test it. So we could write this as a 4x and an x, because we multiply those, we'll get 4x squared. And the way this works is, so we'll find the factors of 27. So we have 1 and 27. We have 3 and 9. And I'm pretty sure that's all of them, actually. So that's not too bad. So with this 4 in here, it makes it a little more difficult. So let's just try this. Okay, 3 and 9 does give us 12 if you think about it, right? So let's say, so the way this this 4x changes things is if this was an x and an x, we could just put a 9 in here and a 3 in here and say, oh, that's what minus, and actually that wouldn't even work because these this -9 times -3 doesn't even multiply to get -7. That gets you +7 because -7 negative is positive. But what this 4 does is put this 4 in here, you have to multiply these n terms. 4 times -3, so that would get you -12, and then you have to add I guess -9. So you have to think about it like this. This is -9 times x, which is -9x, and this is -3 times 4x. It's kind of a reference to the foiling again, with just the x terms, right? -9 times x is -9x, and then 4x times -3 is -12x. So that's how you're trying to find this middle term. So it doesn't seem like this 3 and 9 is going to work for the 4 and x, but there's another way to write this, and because there's more than one way to get 4x squared, you can get, instead of doing 4x and x, you can do 2x and 2x, and we'll still use these terms here. So 1 and 27, pretty sure you still can't get a 12 from that. But let's try a 3 and a 9, because those are the only options left, right? So we're trying to get a -12 here. So let's say I add +9. So if I multiply this, that's adding 18x, and then 3 times 2x would be 6x. We don't know if this is a plus or minus. We don't know if this is a plus or minus either. But if we're trying to get 12 here, we'd want to do -6, right? So let's just do -6x. And we don't even know if this is actually plus either. So this is going to give us 12, right? But we want a -12. So which is bigger, the 18 or the 6? The 18, so you're going to want to subtract the 18, so that we get a negative. So you're going to get -18, right? Put the sign here, and then plus the 6x, and that'll get us -12. So so this 3 times 2x is going to equal 6x, and 2 times -9. 2x times -9 is -18, get -12, and that is your solution. And if we were to set it equal to 0, like some problems were, you'd set each of these equal to 0. So 2x plus 3 equals 0, and 2x minus 9 equals 0. So we're going to move this 3 over, and then divide by 2. So x is equal to -3/2, or -1.5. Move this 9 over, and then divide by 2, and then it can also equal +9/2. So that'd be your solution if it equals 0, and if not, you just keep it as factored form, because if it's not equal to anything, you can't solve it, because it's not equal to anything. It's just like that. So, wow, this looks so ugly. Alright, number 2. So that's pretty much it to factoring. There are some problems in which this doesn't work out so easily. Like you'll get some problems where they're not factorable. You won't get an integer every single time. Sometimes it'll end up being infinite decimals or something, and I'll cover that in the next video, where we use something called the quadratic formula. And you can use the quadratic formula in any case, regardless of how ugly or pretty it looks. It's just factoring tends to be faster. But the quadratic formula is a universal way to solve, to factor, to get the factors of any polynomial. And then we'll also cover completing the square, which is something else, and I'll show you the applications for that in another video. Well, until next time, guys, peace.